Okay, this is a 48RE out of a local farmer's truck. This truck, this trans has 213,000 original miles on it, and he was having some transmission fluid leaks, which is a cracked cooler line fitting back here, and he said the transmission was starting to get a little bit sluggish, and he wanted to just go through and do a build. We're going to do a Towmaster build on it. We're going to tear it down, and we're going to show you what the common wear things are that we see in a trans that has 200,000 miles on it. Okay, Austin did a good job getting this thing all torn apart, and I was going to show you a little bit of what I see on a transmission like this. So really, this transmission was well taken care of. The owner maintenances his truck good, does his oil services, adjusts his bands, keeps a fresh filter in it. So really, this is everything that you could expect in a stock transmission with 200,000 miles on it. So really, overall, it still looked pretty good. Like I said, it was leaking from that crack in the case. But first gear forward clutches look really good. They've got about 5 thou worn off of each clutch. The directs, as you can see here, they have some hot spotting in them. So these hot spots is just from it slipping the clutch as it applies. So over time, as those clutches are going on and off, it is creating heat, and that's often you're towing hard. We are going to try to eliminate that when we do the upgrade on the rebuild by putting a more aggressive clutch in it. We're going to run a GPZ clutch, and we're going to increase our line pressure in the valve body. That's going to give it a little more clutch capacity, because we're going to add one more clutch to this stack with our machine pressure plate in the direct drum, which gives it about a 15% increase clutch capacity, and then we're also going to increase our line pressure, which gives us an increased percentage of holding power. So hopefully the ideal is to be able to rebuild this transmission and be able to go twice as many miles with less wear. Really, the Overdrive clutches look really good for a stock trans. Obviously, if you take a stock truck like this and you put EFI on it and you go out and you race it, you're going to end up tearing up the Overdrive and directs a little bit more. If this truck is pretty much stock power, so again, it was well taken care of. The Overdrive clutch really looks good. there's normal wear area. So the pump bushing has a good bit of wear in it. He was starting to get converter drain back, and if you have more than 3 thou clearance in your pump bushing to converter hub, you start allowing it to siphon fluid from the torque converter back into the pan when it sits overnight. That's when you start the truck in the morning and put it in drive and engages the clutch, but the truck doesn't move because it's got an air bubble in the torque converter. You wait 30 seconds for it to pump its fluid back in the converter, moves you forward again. So in a standard rebuild like this, we're going through, we're replacing the worn bushings, we're replacing all the seals, putting new frictions and steels in it. Basically all the wearable items get replaced. And then along with that, we take little pieces like the factory accumulator piston is plastic and has single seals. We'll put a billet accumulator piston in it that has a dual seal ring here and a dual seal ring here as well. And these are little items that make a big difference in just longevity. Same thing with the servo. The stock servo, second gear servo, is really not that bad, but it has no seal in the center here. So this piston is just a friction fit, and the new seal has a bushing and an O-ring here, so when pressure comes behind here and applies this second gear servo, there's less leakage and you get more holding power in your second gear with the same amount of pressure. So that's the little things that we do when you see here billet servo, billet strut, billet anchor. All those little pieces are just to strengthen your second gear apply. This is your second gear band strut. You can see how skinny it is. We'll show you later then the billet one. It's just basically twice the thickness. We've seen these bend in a L shape, and when those bend, you lose second gear apply and you burn up a second gear band and you have premature failure. So little pieces like this you can upgrade for not too much money when we're rebuilding it, but it really gives you a lot more longevity moving forward. This is the second gear band. This is a stock second gear band that came out of it, and you can see there really is no burn marks on it, so he's not overpowering it. But if I take a caliber and measure it, we're at like 51 thou, and the stock new band starts at like 65 thou. So as the material wears, you're basically wearing your band material off. And like I said, for 213,000 miles, this band looks great. But often what we see in stock trucks that have power added is this band will slip a little bit as it stops the drum every time second gear applies. And eventually this band material wears out and it goes down to metal on metal, kind of like a brake rotor where it goes metal on metal, and then it ruins your third gear drum and your band, and it makes a mess of everything. So really overall, this trans has been doing great for the power that it's making, but we're going to upgrade this to our Towmaster, and our bands that we replace, like this is the second gear band. This has a 8 rivet setup. We go to a Borg Warner flex band that has 10 rivets. We have seen these bands break right here. So a lot of the things we do in our Towmaster build are they're small changes that we've seen failures in the stock form that you're upgrading and making a stronger unit. So a little bit makes a big difference in these transmissions. This is the Overdrive snap ring that holds the Overdrive direct clutch in the basket. There basically you have your big 800-pound spring, and these snap rings are pretty prone to breaking. Now most of the time this snap ring is trapped in a groove to where it can't really come out, but we have seen these things crack in various places and start flipping out, and then that thing comes apart, and then your Overdrive is engaged all the time and it wreaks havoc. So when we do a rebuild, we always use a new snap ring in here just to make sure that we don't have this problem with this thing coming apart down the road and causing a premature failure. Okay, next step on this is get all these parts in the parts washer. We're going to run everything through the cleaner and get the case cleaned and painted, ready to reassemble. Austin will load all the servos and get the overdrive section in, and we'll start the reassembly of the new transmission and get this thing back in the truck today. Okay, we've got this case cleaned and it's ready to go back together, and I'm going to have Austin load the case with the new billet servo along with put the reverse servo back in, and then we're going to start assembling this thing, stacking all the new clutches in it with the new bushings and seals, and put this thing back together. Okay, we've got our loaded overdrive section here, and now we're going to put the overdrive section on here and load the overdrive brake clutch. Rear bearing. This snap ring is what holds all the load for when your overdrive clutch comes on. Flip this over, and we can load the overdrive clutch. Now the factory setup has a solid snap ring, then a wavy snap ring, and then the pressure plate. So what we've done is we removed the wavy snap ring and we machine the pressure plate, and by doing this it gives us room for one extra overdrive clutch. So that's that same 15% added clutch capacity to add more holding power than what you have from the factory. So any guys that run tuners on their trucks, this really is a good idea to add the extra clutch capacity so that you can add that extra horsepower without tearing up your clutches. Here you can see these are our 6 GPZ clutches, and before we put these clutches in the transmission, we're going to put these in fluid to soak them, because all clutches are like a sponge and they will absorb fluid. So you never want to put a dry clutch in a transmission, because if you apply pressure on a dry clutch you can actually ruin the clutch. So we'll let that soak in just clean transmission fluid. We'll soak that in and then we'll stack the clutch and we're ready to go on the trains. And with the steel. So here you have your 6 overdrive clutches, and your overdrive piston is going to apply this clutch. And when the overdrive piston comes on, it actually engages this, it actually decompresses that 800-pound spring and releases the overdrive brake or the overdrive direct clutch that keeps the overdrive planetary from spinning when it's in first, second, and third gear. So when overdrive happens, it releases the small 10 clutches in the rear and engages the 6 clutches in the front. That's why your overdrive clearance is so important. If you don't have your clearance correct for overdrive, you create an overlap to where you'll burn one of these clutches. Properly clearancing the overdrive section, these are the tools that you can buy. You measure down, you can measure the actual clearance. This takes into account if you do have a little bit of case variation from one transmission to the next. That's why it's important to measure each transmission. This one, the measurement, we have all these different selective snap rings, as you can see up here, from 185 thou all the way to 245 thou. This transmission clearances us out where we need a 230 thou shim. We generally add, when we measure down, we will add 10 thou to that clearance to make sure that we release the brake clutch or the overdrive direct clutch before the brake clutch is applied. So this one gets a 230 thou shim, and then this is your measuring tool that where the intermediate selective rides, and this will give us our measurement of the selective that we need to put on the intermediate shaft. So we measure this distance, you go to your ATSG book, and it gives you the measurement correlation for this measurement on which selective shim that you need, and these are these selectives up here. It tells you yellow, red, blue, or green. Oh, they all have different measurements based on color. It just makes it easier for us to identify. So here you can see the selective ring that came off of it has a good bit of wear. So just because you measure this overall thickness doesn't mean that you're going to get an accurate clearance here. So anytime you're rebuilding a transmission, you want to inspect that. And if it is mushroomed from 200,000 miles of crush, you want to put a new selective on it so you do get an accurate overdrive clearance. That's where that 230 thou selective goes, and the Torrington bearing goes on top. This is the overdrive piston that's going to come out and apply the overdrive clutch. Now we've got the overdrive case loaded, we've got our overdrive clearance, and we are ready to put the overdrive extension housing on. Then we're going to flip this thing over on the stand and start loading the front half. Okay, remember how we had this cracked cooler line fitting? We're going to take this fitting out, and Sonics makes this nice repair kit that saves you a bunch of money from buying a new case, and they basically send you a bottoming tap that we can tap this hole about an inch deeper, and then they have this adapter piece that will go in and seal off an inch further in past the crack, and then we're going to put our adapter piece in here, and that will fix our leak that the customer had, and it keeps us from having to buy a new transmission case. I'm going to put assembly glue on this tap, and this is to help us catch the shavings. I'm doing this because I have a lot of people who call us, say they're installing a new transmission, they over tighten their fitting line and they crack their case. So this is how you would repair this case in the truck. You want a little bit of goop or oil on there to where you catch the fittings, where you're not sending shavings in your cooler line, because if you leave shavings in your cooler line, it's going to go into your center support, and if you send shavings right in here to your center support, that will gall up by your intermediate shaft. It'll wreak havoc, and your brand new transmission will not be so brand new anymore. So this is pretty much a bottoming tap. We're just going to run this in here and tap this deeper, and then we're going to run this adapter in. You can see how putting the goop in here kept all the contamination from being loose shavings going on in here, so we can dab out the remaining shavings and keep everything here on the external without anything going on in. Here I am again, just putting some assembly glue in here. I'm just going in here, making sure I get all the shavings out of that, because again, any shaving left in that cooler port will most likely end up with galling your stator support, and it will be bad. So if you do this job in the truck, be extremely careful and make sure that you get all the contamination out of it so you don't cause a problem in the transmission. So there's the repair piece as opposed to what was in there. You can just see you're getting ½ inch further thread, so it's going to seal in here up past the crack. So this fitting's going to go in here like this, and we just tap the transmission deeper, and that should repair that leak. So here we have the third gear direct drum. You see we put a new bushing in it. We've put new seals on the piston, inner and outer. Put it back together, and then we're going to put one extra clutch in this as well. And this is done by machining this pressure plate just on the outside where we can raise the snap ring, or the snap ring rides where it's machined. We still have the strength of the thicker pressure plate. Some people will machine the whole thickness down, but we've seen too much problem with deflection in the pressure plate already, so you really do have to be careful on how you machine these. But this gives us one extra clutch. We can do this without sacrificing clutch thickness. You could get 7 in here if you go to a 65 thou thick friction instead of an 85 thou thick friction. On a truck like this is going for, we're looking for a long haul. We want to make sure this transmission can last the life of the truck, since it's just a farm truck, low power, and we want to give them as much friction material as possible, because it is impossible to build an automatic that does not wear. It's by design, a friction will wear over time, so we want to give him as much friction material as possible. That way, hopefully this transmission will outlast the truck. And then these snap rings are also selective so that we can set our direct drum clearance. We've already clearanced this drum, which clearance came out about 80 thou. The clearance of this drum is directly dependent on the amount of clutches you have in it, what your second gear apply ratio is. So if you run a 5/0 lever, you need more clearance. If you run a 3/8 lever, that's the ratio of the apply. So we've kind of found a recipe that works well for us. We use the TCS billet 4.2 ratio apply lever, and like to be between 75 and 80 thou clearance if we're on a 6 clutch drum. And that keeps us from having a bind up, because if your second gear band is applied onto this drum and is not fully released when the third gear clutch applies, you have what we call a bind up, and it feels like it throws you forward, or you tap the brakes in the 2-3 shift. and that is generally a sign that you are either dragging a second gear band or you're dragging the direct clutch a little bit. So with the 48RE, it's a little bit tricky. It takes the valve body setup, the second gear servo setup, and the direct clutch clearance all into account to get a clean 2-3 shift. This is your forward clutch. So this is attached to your input shaft splines into here, and we have resealed this with new seals on the forward piston. You have to make sure your Belleville spring is clean. We often replace these because that Belleville spring, when that piston engages, has tension on it, so as soon as pressure goes away, it pushes the piston back in and releases it. If you run too much line pressure, or you have a high mileage pressure plate or Belleville spring, that can actually flip or crack, overextend this piston, it blows the seal out, and then you have a forward clutch failure. So the 4 clutches we put in here are going to be the same clutch count as factory, but these are a GPZ, so a little bit more aggressive clutch, and we really do not have forward clutch problems. The only time you mess up a forward clutch is what I say you can't fix stupid, and somebody is brake boosting. Say you come up to a red light and you build 15 pounds of boost because you're going to race that Mustang beside you, and the light doesn't change for 2 minutes, and in those 2 minutes these clutches keep getting hotter and hotter and hotter and hotter. Eventually they will weld themselves together, and anytime that we have a transmission that comes in with welded forward clutches, most of the time it's driver error. The only other time that we have forward clutch issues is if this Belleville spring will flip, overextend the piston, tear the seal, and then you will tear your forward clutch. But these are the 4 clutches that you launch on if you're in first gear, and then these clutches stay on in first, second, third, and fourth. So the only time these are released are in neutral, reverse, and park. So another thing, this is a pressure plate. We need to make sure that this pressure plate is flat. We often take a new pressure plate. If we reuse it, we'll put a new pressure plate on top of it, make sure there's no coning at all, otherwise it's deflecting that new clutch and steel you just put in it. So in a rebuild, it's important to note that your pressure plates are flat, otherwise you create a problem for the new build. Okay, the direct drum, when you run a machine pressure plate, if you have an aftermarket input shaft, this is an OEM input shaft, you need to make sure that your Teflon washer on your input shaft is for sure thick enough to keep from this having this machine pressure plate rub against your forward drum. So on a stock shaft, stock application, like this is a 60 thou and we still have enough clearance, but it is something to check when you're rebuilding it if you're adding an aftermarket or billet input shaft. We're going to spline these clutches on there, and now we have a loaded forward and direct drum that's ready to drop in the transmission. Okay, this is your intermediate shaft and your forward planet and the rear planet, and we have already gone through this and replaced all the thrust washers in this. And then there is also clearance specs in here that we check to make sure that you have proper clearance in your planetaries. There are some people that replace these thrust washers with Torrington bearings, and while that's great, it's all well and good, we have not really found any problems that are related to the thrust bearings. As long as your bearing, your planet clearances are correct, your end plate clearances are correct, we do not have problems with the factory thrust washers, even in high horsepower applications. So if you want to put a Torrington bearing application or setup in it, you can, but it really does kind of make it a problem as if down the road, if you have a planetary problem, or if we have a core that comes in that has it, we kind of have to stick to that whole setup, or we have to change this whole stack, or we have to go machine new parts. I have not seen a problem with the thrust bearings enough to justify the time and money spent to put the Torrington bearings in it. If people want to do it, I don't think it's a bad idea, but I personally, all the time, it's a Pro Street quad cab, we always just run the factory thrust washers, and as long as our clearances are correct, we have not had a problem with it. Once this is dropped in, you just got to make sure you line the planetary splines up with the reverse drum, and then you can just push it on in, and this is ready for the forward stack. Okay, on the back of your input shaft is what we call a Mickey Mouse washer, and then this is the washer that goes on the intermediate shaft, and this is so when your transmission has thrust load, that way there's no galling between the back of your input shaft and the tip of your intermediate shaft. Those are also selective, so we can change those if we need to change our end plate clearance for any reason. Most of the time we will put it together with what I had before and then measure our end play, and if we need clearance we'll adjust as needed. Okay, this is our new second gear band. Said these have 10 rivets as opposed to the factory 8, and it's a solid band in here. These are, you can spend a lot of money on second gear bands with rigid bands, fancy stuff. We have had really good luck with these. The rigid bands, there are some that have a larger footprint on it, but for our average trucks, this is the band that we use, and we have had great results with these. We've got guys running lockup on lock 2-3 shifts, and they have not broken the band like they have with the stock ones. You can see this band goes around the third gear drum, and this band will actually stop this drum from spinning and engage the planetary gear when it goes into second gear. Okay, so this gives you a good visual of how band adjustment works. The looser your band adjustment is, the more slack there is in this band. So if your band is too loose, your servo piston comes out and applies, and you don't have a good grip on this drum, and you end up burning your band and causing a premature failure. So when we ask you guys to periodically check your second gear band adjustment, that is why. So as this band material wears, this adjustment comes loose. And on a stock truck, work truck, generally every 25-30,000 miles is sufficient on adjusting your band. But the guys that are making horsepower, the more power you make, the more often you need to adjust the second gear band. Here we have our pump. This has a new bushing put in it, has a new seal in it. The pump gear, clearance, everything clearanced out great. So we put lube on everything to put on the new bearings. When it goes together, you always want to put assembly lube on these bushings so that when you start your truck, before you get fluid to it, that you don't gull up the bushing on a brand new bushing. That's what the assembly goo is there for. Here generally we'll just put 2 bolts in, tighten them up, check our end play clearance before we go and do finish tightening. Setting end play clearance. I usually take a pry bar and just make sure that the input shaft is pushed all the way tight. This is where we pick up on the input shaft, and you can see we have about 35 thou clearance. So the factory spec is from like 30 to 80. We always try to be on the bottom end of the clearance between 32 and 35 thou, so that is right on. These all get torqued to 15 foot-pounds, and we are ready for a valve body and get this thing back in the truck. Okay, this is the valve body ready to go in. We did not get this on video. I was going, we'll maybe do this on another one. Matt Sensenig went through this. He goes through every valve body top to bottom, cleans it very thoroughly, checks vacuum in all the bores, because a lot of on the high mileage ones like the throttle valve and the switch valve often get excessive wear in it, the PR valve, and that creates a leak. Well, you cannot buy a brand new valve body anymore, so we are always refurbishing different bores. So if a bore is really bad, we can bore it to a 15 thou oversize. Sonics makes a lot of equipment that we can vacuum test, use their jigs to bore and oversize and repair these valve bodies. So this valve body looked a lot like the transmission. It looked pretty good inside, so we were able to go through, clean everything up, do the modifications for the higher line pressure. We don't go aggressive with lockup because we don't want it to shift very hard because it has a stock input shaft, stock intermediate, stock output. We're really looking to get longevity out of these Towmaster transmissions. So this is for the average guy that wants to work with his truck, add a little bit of horsepower, get better fuel economy, and have a transmission that lasts a long time. Before we put the valve body in, we're going to do final adjustment on the band. Reverse band gets set to 72 inch-pounds in. Then you back it off 3 full turns and tighten the jam nut. The second gear band gets 72 inch-pounds in and backs off 2 full turns. Here we can apply compressed air to the second gear servo. And that tells us that we have a good solid seal in the servo. Pressure to the reverse servo. And that basically verifies that we didn't roll a seal or anything going in. We do the same thing for the forward drum and the direct drum. Just gives us the assurance that we didn't roll a seal putting the pistons in. And that's how we can do a quick check to make sure that we didn't mess anything up before we install in the truck and figure out if we don't have a gear. These get torqued to 100 inch-pounds. With the valve body, we put all new electronics in. New valve body wiring harness, new governor pressure solenoid, which is the oversized Borg-Warner solenoid, a Rostra high pressure transducer, and then we'll put our Firepunk double deep pan on. That holds an extra 5 quarts of fluid. We'll also move his transmission temperature sensor that he had in his second gear, or in his line pressure port. We'll move it to the pan so we can get a more accurate sump temperature, and we're ready to bolt this thing up. This is ready to go back over to Landon. He's going to get this thing installed in the truck and put it on the road. Another important part of installing a transmission is cleaning the cooler. So we have a hot flush machine that runs 185-degree fluid through the cooler and also back purges it and makes sure that we have no contamination left in the cooler. So if you're doing this at home, you have to make sure that you get a clean cooler. If you have metal contaminants in your broken trans that you took out, it's going to be in your cooler. If you can't hot flush it, you should replace your cooler. It is very important, and we have saved a lot of transmissions. Once we started doing the hot flush, we learned how much contamination we're really getting out of these coolers. So here you can see the screen. These are just a bunch of small little aluminum fragments that came out of the cooler system, and we're just getting these. This is a 10 micron, then we'll put a paper on it, get it down to 2 micron, and get the coolers completely clean before we hook this up to the new transmission. Okay, I'm going to let Landon get this thing back in the truck and put this truck on the road, and hopefully this will give the customer another 300,000 miles and outlast the truck. So trucks like this, once they get to 500,000 miles, guys are usually about ready to trade them in on a new one anyway. So thanks for watching. I hope you guys enjoyed. Hope you learned something. If you guys have more questions about transmissions, we'd be glad to explain everything that we do here at Firepunk, and we'll see you guys next time.